This example is very similar to the last one. We'll start with the simple probabilities. The probability of C is there's 120 people who live in the city out of the 150 people who took the survey, which gives us a probability of C of 0.8. The probability of C complement, you can use the complement rule if you'd like here, 1 minus 0.8, which is 0.2. The probability that someone favors combining city and county government, there were 100 people who favored combining city and county government out of the 150, which is 0.667. The probability of C and F, the probability that someone lives in the city and favors combining city and county government, there were 80 people in that overlap out of the 150 people, which is 0.533. The probability of C or F. Once again, there's a couple ways to do this. In this case, I would probably use the addition rule and say the probability of C plus the probability of F minus the overlap of C and F. So if you do this, you get the probability of C is 0.8. The probability of F is 0.667 minus the overlap is 0.533. Which gives us an overall probability of 0.93. Well, if you calculate it without the addition rule, you get 0.933, but you get a little rounding error here, so you get 0.934. But that's really not a big deal. Number 6, the probability of C given F. So given F, there were 100 people who favored combining city and county government, and out of those 80 lived in the city. So you get 80 over 100, which is 0.8. The probability of F given C, there were 120 people who lived in the city, and out of those 80 favored combining city and county government, which is 0.667. So those are the probabilities, and then the main point of asking this question was really, does living in the city affect whether or not someone favors or opposes combining city and county government, or basically are C and F dependent or independent? And in this case, what you really need to look at is remember the definition of independence. The definition of independence basically says that the probability of A equals the probability of A given B. If that's the case, A and B are independent. So in this case, if the probability that someone favors combining city county government is equal to the probability they favor combining city and county government, given that they live in the city, if this is a true statement, then these are independent. So in this case, these are independent. And the reason being is because of this relationship. The probability of F equals the probability of F given C, which means living in the city does not affect whether or not someone favors combining city and county government. And in cases like this, I could change the numbers and make these dependent. So keep in mind that you have to check the math here in order to determine whether or not the events are independent.